Welcome to Tech Orbit. Enjoy this super video and don't forget to subscribe so you don't miss the next ones.
Something weird is happening on the planet Venus. We know that Venus is the most Earth-like planet in the solar system, practically our twin sibling. So in theory, this place should be very familiar to us, but in reality, Venus is so incomprehensibly strange that we still understand very little about the true nature of this planet. So are we looking at a vision of the future? The nightmarish end that awaits all planets, or is Venus a memory of our past? Of a time when the Earth itself was a young, hot volcanic wasteland. The real secrets lie beneath the surface and above the clouds. This is the mystery of the planet Venus. We know that there are many similarities between Venus and the Earth. Both planets are very similar in size and mass. They have the same rocky composition. They orbit in a relatively similar proximity to the Sun. But one of the stranger similarities between the two planets is that both Venus and the Earth have a young, rejuvenated surface. So what do we mean by that? Well, if you look at the surface of Mars, Mercury, or Earth's moon, you'll find a dense pattern of impact craters. These are the remnants of multi-billion-year-old asteroid impacts that occurred when the solar system was young and still full of rocky leftovers from the formation of planets and moons. The Earth was not spared from this ancient bombardment. Our surface would just be as pockmarked as the moon if not for the continuous rejuvenation of plate tectonics. The Earth is constantly recycling mass from the surface down into the mantle and creating new land through volcanic eruptions. The surface of Venus appears to tell a similar story. The ancient battle scars have been wiped away, leaving the age-old Venusian surface at somewhere between 300 million and 1 billion years old, except Venus does not have plate tectonics. Instead, it has one continuous and stagnant lid of rock that surrounds the entire globe. So there's no easy explanation as to how the entire planet has been resurfaced in such a relatively small amount of time. Even 1 billion years on the cosmic scale is fairly young. You don't need tectonic plates to have volcanic activity, and this is how we identify that Venus has a stagnant lid for a surface on the Earth. Active volcanoes are concentrated along the borders between the tectonic plates, while on Venus there are thousands of volcanoes spread out across the surface in a seemingly random distribution. This would indicate that volcanoes simply spring up at any location where the surface crust is thin and that their formation is not driven by physical movement. We have evidence that volcanic activity on Venus continues to the present day. But this still doesn't fully explain the resurfacing event. Planets with a stagnant lid will have lower overall volcanic activity than similar planets with tectonic plates on the Earth. Volcanoes sweep back and forth across the surface over millions of years, violently reshaping the land as they go, while on a planet like Mars, volcanoes just sit in the same place for millions of years, slowly and steadily erupting until they form gigantic mountains like Olympus Mons, the highest peak in the solar system. Actually, most of the highest mountains in the solar system are located on Mars thanks to its stagnant lid and stationary volcanoes. You would think that a similar thing would happen on Venus, but that's not been the case. It does have a couple of very tall mountains, but overall the surface of Venus is much closer to Earth than it is to Mars, which still leaves us wondering just what the hell happened here. One of the more interesting theories about the resurfacing of Venus is that it all happened fairly abruptly in an explosive global cataclysmic event. The idea is that the stagnant lid of the Venusian surface probably traps in a lot of pressure underneath the surface, and since Venus is pretty close to the Sun, much closer than Mars, there is the likelihood that a lot of thermal energy could build up inside the planet over hundreds of millions of years, and eventually this pressure is going to reach a point where it can't be contained any longer, releasing as one. If you're enjoying the video, don't forget to subscribe so you don't miss a video. Catastrophic global volcanic eruption. If Venus did burst like an overfilled balloon at some point within the past billion years, this would explain everything that we see on the planet today. After the volcanic pressure release, the planet would cool back down into a freshly resurfaced globe. Unfortunately, this cataclysmic event permanently erased any surface evidence of the ancient past on Venus. When we look at the planet Mars, we know that there was a time when liquid water flowed over the surface in ancient rivers, lakes, and even oceans. If a relatively small and cold planet like Mars could support the necessities of life, then it stands to reason that Venus probably could have done the same in order to find the proof we need to move up. We know that the atmosphere on Venus is incredibly hostile. We know that it's caused by a runaway greenhouse effect, but we're not entirely sure how it got that way to begin with. The surface pressure of Venus is 92 bars. That means the air is 92 times more dense than what we find at the surface of the Earth. The majority of the Earth's atmosphere is actually composed of nitrogen, one of the most common elements in the known universe. It accounts as for around 78% of the air. Oxygen is only around 21%, and the remaining 1% is mostly an inert noble gas called argon and zero. Atmosphere is occupied by greenhouse gases like carbon dioxide, methane, and ozone. Interestingly enough, we know that Venus has around the same mass of nitrogen in the atmosphere as Earth does, and there are even detectable amounts of molecular oxygen on Venus, but that is all dwarfed by an unfathomable amount of carbon dioxide. In the Venusian atmosphere, it makes up over 96% of the total composition, and at 92 bars of density, that is a lot of carbon dioxide. But where does it all come from? The Earth manages its own carbon dioxide through a natural cycle. CO2 is absorbed by plants. They die, they fossilize, and then plate. Tectonics eventually pull the fossils down deep into the mantle. Then humans came along and started burning the fossils and putting them straight back into the atmosphere. But that likely wasn't the case on Venus, and it's also not likely that Venus just happens to have a massive amount of excess CO2 that the Earth does not, as far as we can tell. Venus and the Earth started out as nearly identical balls of molten rock. The chemical composition should be more or less the same, meaning that some kind of natural force moved all of the excess carbon from the inside of the planet to the outside and created the runaway greenhouse effect that has superheated the planet's surface. This could have happened during the planet-wide cataclysm. That would be a reasonable explanation, meaning that Venus hasn't actually been what it is now for all that long. Venus is closer to the Sun than the Earth, but only by around 30%, which is not enough to cause a huge difference in temperature. If you take the excess atmosphere out of the equation, the average surface temperature of Venus would be around 70 degrees C, which is still too hot, but it's as close to Earth temperature as we would ever find anywhere in the solar system. In fact, it's very likely that there was a time when the atmospheric conditions of Venus were very similar to the Earth, complete with large amounts of liquid water. Now, like we said earlier, any geological evidence of flowing water is long gone from the surface of Venus, but the chemical evidence does remain. This comes in the form of an atom called D-dum. Okay, stick with me here. Dium is an isotope of hydrogen, which basically means that dium is a unique variant of hydrogen that is created by the addition of a neutron inside the core of the atom. Typical hydrogen only has one proton in the nucleus, while dium has a proton and a neutron inside the nucleus. This gives dium a heavier atomic weight than hydrogen, and on Earth there is typically...
That's it for today's video. Don't forget to subscribe, like, comment and activate the notification bell so you don't miss any videos. See you soon.